So we've been working on some graphing, and we've already completed some examples where it's f of x equals a number over x. So an example of that could be f of x equals 7 over x, so some number over x. Then we had our HK example, so it might look like f of x equals 7, maybe x minus 2 in the denominator, plus 3. And our third example would be where we have an x in the numerator and the denominator, so it could look like f of x equals 2x plus 3 and maybe x minus 2. So the function that we're going to look at today is f of x equals p of x over q of x, where p of x and q of x are polynomials. So an example of that might be, we could say f of x, or we could say y equals x squared plus 3x minus 4, and then we have an x minus 2 in the denominator. So it's rational because it's some value divided by another, and it doesn't match any of the three examples that we have above. Notice that we have an exponent of 2 that we're dealing with here. So for this type, you can see, and I have it typed in here, and I would put this in your notes, that we're going to determine the x-intercepts by finding the zeros of p of x, or the numerator, and the vertical asymptote is going to be the zeros of q of x. And so sometimes it might be 1 0, or it could be more than 1. So let's look at an example from our textbook. Y equals 6x squared plus 1. So when we're looking at this numerator and we're trying to determine the x-intercepts, it says it's when it's the 0 of the numerator. So if we set 6 equal to 0, we're not going to be able to solve for an x value. So because there's no x term in the numerator, there's no x-intercept to find. All right, so let's see if we can set our denominator equal to 0. And if we can find that, then we're going to find our asymptote. So we'll say x squared plus 1 equals 0. Subtract 1 from both sides. X squared equals negative 1. And we're not going to be able to find the square root of negative 1. It's going to be no real 0 or imaginary. So there's no vertical asymptote. And then next I'm going to pull up my calculator and we'll check our answer there. So again, before we check with the calculator, make sure that you paused the video and you wrote down how to determine our x-intercept and the vertical asymptote. That's really important. And in a little bit we'll check on the horizontal asymptote. Okay, you'll recall that our function was y equals 6 over x squared plus 1. So on the calculator, that's where I typed that in. And then when I hit graph, you can see that there's no x-intercept. That's what we said. And it doesn't cross. It gets really, really close to our x-axis, but our line is not going to cross. We also said there was no vertical asymptote. And this is our y-axis, but it's not our asymptote in this instance. And we'll take a look at some that actually contain a vertical asymptote. All right, so here's another example, and the first thing we're going to do is determine what our x-intercepts would be. So we're going to look at the numerator, or the top. So we're going to set that equal to 0 and solve for x. So 2x squared equals 0. Divide both sides by 2. X squared equals 0. Square root, x is going to be equal to 0. And then I took the liberty of graphing it, and you can see that we have a meeting up here at the origin or at 0. So our x-intercept is at 0. Then we're going to determine the vertical asymptote. And to do that, we're going to look at the denominator. So we say x squared minus 9 equals 0. We add 9 to both sides. X squared equals 9. We take the square root of both sides. So x equals plus or minus 3. So here we actually have two asymptotes. And you can see here and here that our lines are not going to cross at -3 or 3. We just looked at how to find the x-intercepts and the vertical asymptotes, but now we're going to find the horizontal asymptote. So that's what this chart down here is for. So you'll want to pause the video and copy this down. The key to the horizontal asymptote is going to be looking at the degrees. You'll see the degree is key. So in the first line, it says if the top degree is less than the bottom degree, then the horizontal asymptote is going to be at y equals 0. But the degrees are the same. And if you remember, the degree is the highest exponent in the polynomial. So these are both squared. So this one does not apply. Then it says if the degrees are equal, which in this case they are, we're going to divide the coefficients to find the horizontal asymptote. So we'd put a 1 here. So of course 2 divided by 1 equals 2. So our horizontal asymptote is going to be 2. So y equals 2 for this particular function. And then the third one says if the top degree is greater than the bottom degree, then there's no horizontal asymptote. And again, that one does not apply to this particular example. So the key ideas for this entire lesson are on this slide. How to find the x-intercepts, the vertical asymptote, and then the chart down here on how to find the horizontal asymptote.